The universe's fine-tuning. Imagine the universe as a giant game show with a control panel full of knobs and levers. Each knob controls a fundamental constant of physics like the strength of gravity, the mass of an electron, or the speed of light. It's like a cosmic game of Price is Right, where the stakes are the very existence of life. Here's the catch. If you tweak any of these knobs even slightly, the universe goes haywire. Stars might not form, atoms might fall apart, or the whole universe could collapse faster than a contestant on a losing streak. But here's the real head-scratcher. It turns out, all the knobs seem to be set perfectly for life to exist. It's like someone rigged the game show just for us. So, how did we get so lucky? Here are some possible explanations from the cosmic game show host. Pure luck. We just happened to win the cosmic lottery, like a contestant who guesses the exact price of a car on the first try. Our universe is just one of many universes out there, each with its own set of knob settings, and we just happened to land in the one that's perfect for life. Unknown rules. Maybe there's some hidden rule book that says the universe has to be fine-tuned for life, like a secret clause in the game show contract. We just haven't figured out that rule yet. Divine intervention. Some folks believe a cosmic game show host set up the universe specifically for life, like a benevolent being who wants us to win the ultimate prize, existence. Extra dimensions. So, you think you know your way around the universe. Up, down, left, right, forward, backward, got it? But what if there were secret passageways, hidden rooms, and cosmic crawl spaces that we just can't see? That's where the idea of extra dimensions comes in. It's like the universe has a bunch of secret closets we haven't discovered yet. Imagine tiny, curled-up dimensions, like little hidden pockets of reality tucked away beyond the three we're familiar with. They're so small and tightly rolled up, we'd need a microscope the size of a galaxy to see them. It's like trying to find a lost sock in a black hole. These extra dimensions aren't just a sci-fi fantasy, though. Theories like string theory, which tries to explain everything in the universe, yes, everything, suggest that these hidden dimensions might be the key to unlocking some of the cosmos' biggest mysteries. They could explain why gravity is so weak compared to other forces, like a shy party guest hiding in the corner, or they might even be the hiding place for dark matter and dark energy, the universe's mysterious stuff that we can't see. The universe's grand finale. Alright, folks, time to grab your popcorn and settle in for the universe's epic conclusion. Imagine the cosmos as a giant balloon that's been inflating since the Big Bang. What happens when the party's over? Let's explore the possibilities, the big freeze. Imagine slowly letting the air out of that balloon. Everything gets farther and farther apart, the music stops, and the universe becomes a cold, dark, and lonely place. It's like the ultimate cosmic snooze fest. The Big Rip. This ending is more like a wild party gone wrong. The balloon expands like crazy, growing so fast it explodes, sending galaxies and stars flying like confetti. Talk about a cosmic mess. The big crunch. Now, imagine the balloon deflating and collapsing back on itself. Everything comes crashing together in a giant cosmic group hug, potentially leading to another Big Bang and a brand new universe. It's like the universe hitting the reset button. The Big Bounce. This one's a bit like a yo-yo. The universe collapses in on itself like in the Big Crunch, but then it bounces back out, starting a new cycle of expansion and contraction. It's the ultimate cosmic dance party, with the universe doing the limbo over and over again. Quantum entanglement. Imagine you have two coins magically linked together. You flip them both, and one of them falls head down. Instantly, you realize that the second coin must be tails, even though it is miles away from you. It's like quantum entanglement, only with tiny particles instead of coins. In the wacky world of quantum mechanics, particles can be linked together in a way that would make even the closest BFFs jealous. When the particles are entangled, they're like a cosmic couple that finish each other's sentences. Measure one particle, and you instantly know something about its partner, no matter how far apart they are. It's like they have a telepathic connection that would make Professor X jealous. This spooky action at a distance, as Einstein called it, isn't due to some secret signal or hidden message. It's just a fundamental part of the quantum world, like the universe's way of saying, hey, these particles are BFFs, and they're sticking together no matter what. Quantum entanglement has been proven by experiments, and it's one of the weirdest and most fascinating things about the universe. Cosmic rays. Picture this, tiny, super-fast particles are zipping through space like cosmic ping-pong balls, some even faster than anything we humans can create. These are cosmic rays, the universe's rowdy party guests, crashing into our planet from every direction. But where do these energetic party animals come from, and how did they get so hyped up? That's the big cosmic mystery. Here's the lowdown on these party crashers. They're always crashing the party. Earth is constantly bombarded by these cosmic rays, passing through us and everything around us like invisible party goers. Don't worry, though most of them are harmless. They're just here for a good time. They've got some serious moves. These particles are packed with more energy than a toddler after a sugar rush, some even more powerful than anything we can create in our biggest, baddest particle accelerators. They're from out of town. The most energetic cosmic rays probably come from way outside our galaxy, perhaps from exploding stars or supermassive black holes throwing the wildest parties in the universe. Quantum gravity. Imagine you have two sets of Legos, mega blocks. These are like the rules of gravity general relativity, perfect for building massive spaceships and epic castles. They explain how planets, stars, and galaxies move and groove across the cosmos. Teeny tiny Legos, these are like the rules of quantum mechanics, ideal for building microscopic robots and itty-bitty race cars. They describe how atoms and subatomic particles do their crazy quantum dance. The problem is, these two sets don't really play well together. Try building a skyscraper with teeny tiny Legos and it'll crumble faster than a cookie in a toddler's hand. And trying to understand atoms with mega blocks. Good luck with that. That's where quantum gravity comes in, like a magical Lego set that combines the best of both worlds. It's the ultimate building block kit, allowing us to construct anything from black holes, the universe's ultimate vacuum cleaners, to the very beginning of time itself. The matter-antimatter asymmetry. Imagine the universe threw a massive party right after the Big Bang, inviting both matter and antimatter. Matter brought the protons, neutrons, and electrons, the building blocks of everything we see. Antimatter, being the cool, opposite twin, brought their own funky anti-versions of these particles with the same mass but rocking the opposite charge. Now, here's the cosmic conundrum. According to the guest list, there should have been an equal number of matter and antimatter party-goers. But when these two meet, they annihilate each other in a flash of energy, like a dance floor brawl that ends in a puff of smoke. So, if there were equal numbers, the party should have ended before it even started, leaving nothing but a faint echo of "oops, sorry." But wait a minute, we're here. The universe is filled with galaxies, stars, planets, and even us humans, all made of ordinary matter. So, where did all the antimatter party crashers go? Did they get lost on the way? Did they decide the music was lame? This, my friend, is the mystery of matter-antimatter asymmetry, the universe's ultimate case of a lopsided party. Scientists are still scratching their heads over this cosmic puzzle. Perhaps the antimatter are SVPD, yes, but then goes to the party. Or maybe there's some hidden rule that we haven't figured out yet, like a secret VIP room where all the antimatter is hanging out. Whatever the answer, it's clear that the universe has a preference for matter, and we're just lucky enough to be on the winning team. The nature of time. Time is a slippery fish, always moving but never quite graspable. Einstein, the ultimate cosmic comedian, showed us that the faster you move, the slower time flows for you compared to someone standing still. It's like the universe's way of saying, hey, speed demons, take it easy and enjoy the ride. And things get even weirder with gravity. In strong gravitational fields, time slows down like a sloth on vacation. This means time flows a bit slower on Earth's surface than it does for astronauts orbiting above us. So next time you're feeling stressed, just blame it on Earth's gravity slowing down your personal time. But the cosmic punchline is that we still don't understand time's full routine. Did time have a beginning, like a grand opening act? Or has it always been here, like a never-ending improv show? Will time ever end, like a curtain closing on the universe? Or will the show go on forever with new acts and surprises popping up along the way? How does time work on the quantum level, like a microscopic comedy club? That's where things get really bizarre, with particles doing their own time-bending routines that would make even Einstein's head spin.